Hi, this video is going to talk about the Pythagorean Theorem. So the learning goals are to understand the Pythagorean Theorem as a relationship between the squares of the sides of a right triangle, and also to use this Pythagorean Theorem to calculate the missing length of the right triangle. So before we go further, I just want to go over some terms. Well, this is a right triangle because we have a right angle over here. The side that's farthest away from the right angle, okay, is called the hypotenuse. And we can always find that side if we know where the right angle is. If we draw an arrow from the right angle, it's always pointing to the hypotenuse, which is also always the longest side of a right triangle. And the other two sides we call legs. Okay, so here we have two examples of right triangles. Now, if we take a look at the lengths that are given to you, we notice that there's really not much of a relationship between the three sides here or the three sides there. But something really interesting happens when we create squares out of those sides. Okay? Let's say we find out the areas of these squares. So we always do length times width to find out the area of rectangles or squares. So the area for this little square here would be 3 times 3, which is 9. The area of this is 4 times 4, which is 16. And the area of this square would be 5 times 5, which is 25. Now, if you take a look at these numbers, okay, you can see that 16 plus 9 makes 25. Right? Or also, if you think about it in terms of subtraction, right? 25 take away 9 makes 16, or 25 take away 16 makes 9. Now, is that true of the other right triangle? Let's calculate the areas here. So this little square, 5 times 5 makes 25, 12 times 12 makes 144, and 13 times 13 gets 169. So, do the two orange squares here add up to 169? Well, yes, they do. So this relationship holds true for this second triangle as well. Now, these are right triangles, but is this true of, let's say, triangles that aren't right-angled triangles? So here we have an example of one that isn't a right triangle. Let's create squares out of its sides, and let's see if this relationship holds true. So here the area of this square would be 4 times 4 is 16. Here we have 7 times 7, which makes 49. And for the larger purple square here, we have 10 times 10, which is 100. So we can see that 16 plus 49 doesn't make 100. So this relationship that we just saw with the other two right triangles, it doesn't hold true for this triangle here. Okay. So let's just kind of sum up what we just found. So the square on this side, which remember we called the hypotenuse, so the square of the hypotenuse, okay, is equal to the sum of the squares of the other two sides, which we call the legs. Now, instead of using numbers here, we're just going to label them using letters A, B, and C. So if C is the hypotenuse and A and B are the legs, then we can express this relationship called the Pythagorean theorem as follows. Okay? So the area of the large purple square, right? That's C times C, which is C squared. Okay? Well, that's equal to these two squares added together. So the area of this one would be A times A, which is A squared, plus the area of this square, B times B, which is B squared. So this is the famous way of writing the Pythagorean theorem. There's also a way that we said there was a subtraction method, right? So one of these squares, okay, A squared, recall, was the same thing as the larger square, right? C squared, subtract the other square, which is B squared. Okay, so we've got two versions of the same relationship, and we're going to use both in different situations. We use Pythagorean theorem primarily to figure out the lengths of the missing side, and I'll show you how we do that. So here we have some examples of right triangles with a missing side. So here we seem to be missing the hypotenuse, okay, which remember we labeled C. And the other two sides we can label A and B. Honestly, it doesn't matter which one is A or B. So let's come up, let's write down the Pythagorean theorem here. C squared is equal to A squared plus B squared. So I don't know what C is, so I'm just going to leave it as C. I know what A is now. A is 8, so that's 8 squared, plus 15 is B, so I'm going to write 15 squared. So C squared is equal to, now 8 squared, that basically is finding out the area of that invisible imaginary square. Okay, that's made up of the side of that triangle. So 8 squared is the same thing as 8 times 8, which is 64. And 15 squared, well, that's the area of that invisible square as well. So that's 15 times 15, which is 225. So C squared now is equal to 64 plus 225, which is 289. So that's the area of that square that is made up of the hypotenuse. But I don't care about the area of that square. I really only care about the side length. So to come up with the side length of that square, I write the square root. So I'm going to take the square root of that number of 289. I'm going to get a calculator here just to show you. So 289, the square root of that is 17. So C is equal to 17. So when we take the square root, we're basically saying what number times itself gets me 289. Now remember, to find out the area of that square, it would be that some number times itself to get 289. So the square root helps me to find that original number. Okay. So that side length is 17 meters. The bottom question is very similar. So what I'd like you to do is to try the second question. Okay. Looking at the example at the top. Okay. Write down the Pythagorean theorem, go through the calculations, and see if you can find out the missing side length. So pause the video, give it a shot, and good luck. And press play when you're ready to view the answer. All right, so we're missing the hypotenuse here, so that's the letter C, and I can write A and B to label the other two sides. So we can use the Pythagorean theorem, okay, to find out the missing side. So C squared is equal to, well, A is the side length of 8, so that's 8 squared plus 6 squared. So 8 squared is just 8 times 8, so that's 64, plus 6 squared makes 36. So C squared is equal to 100. So if the area of that square is 100, I need to know one of the side lengths. So again, I take the square root to find that out. Okay. So the square root, okay, of 100 is 10. So C would equal 10 meters. Okay. So that's how we find the missing side of a right triangle, specifically the hypotenuse. Now, what if the missing side isn't the hypotenuse? So we would use the other version. Okay. So first of all, when you're using the Pythagorean theorem, make sure that you're actually dealing with a right triangle. Because if it's not a right triangle, remember, the Pythagorean theorem doesn't work. Now, if the missing side is the hypotenuse, like those two questions were, we used this version of the Pythagorean theorem to help us figure out the missing hypotenuse. But if it's one of the legs, instead of using the version with C squared, we're going to use the version with the A squared, which remember was just the large square subtract one of the other squares. Okay. Now, we'll show some examples of finding out one of the missing legs. So here, the hypotenuse is given, right? This arrow points to the hypotenuse, so it's provided to us. So this side is C. The missing side we'll call A, and the side that's given to us will be side B. So here, because we have the hypotenuse, we're not going to write C squared. We're going to write A squared is equal to C squared minus B squared. Now I don't know what A is, so I'm going to keep it as A. C we see here as 8.5, so it's 8.5 squared minus 3.8 squared. Now I just wanted to put decimals here just to show you that this works fine with decimals as well. So we need to figure out what that is. So 8.5 squared is 72.25. Subtract 3.8 squared, which is 14.44. So now we just subtract them. Right? So 72.25, take away 14.44 is equal to 57.81. But if I want A from A squared, right, I take the square root. So A is going to be, and I just push one button, and I get 7.6 meters, roughly. Okay. So again, because we're not missing the hypotenuse, but we're missing one of the legs, we're going to use the subtraction version of the Pythagorean theorem to help us find out the missing side length. So the second question is very similar. So why don't you label the three sides, okay, A, B, and C, write down the proper version of the Pythagorean theorem that you're going to use, crunch the numbers, and see what you get. So pause the video, and again, when you're ready to view the answer, just press play. Okay. So the missing side, okay, is one of the legs. This side here is the hypotenuse. So we're going to label this side C, this side B, and the missing side A. So we're going to write A squared is equal to C squared minus B squared. A squared is equal to, instead of C, right, we know what that is. That side is 8.2 meters. So we're going to write 8.2 squared minus 7.1 squared. So A squared is equal to, well, we'll just figure this out. That's 8.2 squared. So 67.24 minus 7.1 squared, 50.41. So A squared now, we're going to subtract those two numbers. So 67.24, take away 50.41, 16.83. Now again, we want to get A from A squared, so we're going to take the square root here. And 16.83, if we take the square root, we get 4.1. So A here is 4.1 meters. Okay. So the Pythagorean theorem helps us find out the missing side, whether it's the hypotenuse or the legs. So let's just sum it up. So for a right-angled triangle, the sum of the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now if we take a look at the simulation here, okay, this is a very cool animation. That's from Wikipedia. It shows that the areas of the squares of the two legs, right, makes up the area of the square of the hypotenuse. Now, the Pythagorean theorem, okay, just to drill it in your head a little bit more, we usually write it as C squared is equal to A squared plus B squared, or you can think about it as A squared equals C squared minus B squared. Okay. Now, this Pythagorean theorem can be used to determine the missing length of a right triangle. So we just came up with two basic scenarios. Okay. So I hope that this video has made things clear, and best of luck using the Pythagorean theorem.